we're going to take the derivative of y equals ln of 1 over x cubed plus ln of e. And a couple things we can do. One thing, we can do some simplification before we take the derivative. Ln of 1 over x cubed from properties of logs could be written as ln of 1 minus ln of x cubed. And then ln of e is actually just 1. And we can actually take this a step further. That 3 can come out front. Ln of 1 is 0. So we have negative 3 ln of x plus 1. Now what we'll do is we'll do the derivative both ways so we can see that it comes out the same regardless of what we do simplifying wise. So let's just say we start from the original and then we can see really quickly the derivative from here. But ln of 1 over x cubed is a chain rule. So derivative of natural log, you take 1 over whatever you're taking the natural log of times the derivative of what you're taking the natural log of. So we have to take the derivative of 1 over x cubed. As a reminder, 1 over x cubed is x to the minus 3. So from our power rule, the negative 3 comes down in front and will decrease the power by 1. So this will actually 1 over x cubed. When we divide by a fraction, we flip and multiply, so that becomes x cubed. This, our derivative, we're going to have negative 3x to the negative 4. Now we can do the simplification from here, or maybe it'll be easier to see if we rewrite this guy as negative 3, and now because the x is to the minus 4th over x to the 4th. The negative 3 is not to the negative exponent, which is why it stays in the numerator. Now we see our cancel. 3 of those x's with 3 of those, and we get minus 3 over x. Well, if we were to look at our function here, the simplified version, y equals negative 3 ln of x plus 1. And I think I forgot to mention derivative of ln of e is 0 because it's a constant by itself. And if we weren't sure, we'll definitely see it here. The derivative of 1 is 0. So we have negative 3 times the derivative of ln of x, which is 1 over x. And there's our negative 3 over x. A lot of times we like to simplify before we can take the derivative, because as you can see, it ends up being a little bit less work and less opportunity for error. So always try and simplify before you take your derivative.